What if everything we perceive is not as it seems? What if our reality, the solid ground we walk on, the stars we gaze at, is all just an illusion? These questions have haunted philosophers and scientists for centuries. Today, cutting-edge physics is bringing us closer than ever to understanding the true nature of reality. Our senses paint a picture of a concrete world, a world of objects existing independently of our observation. But quantum mechanics, the physics of the very small, tells a different story. It reveals a reality that is fluid, uncertain, and intimately connected to the observer. This begs the question, is our universe an illusion? While we may not have all the answers, exploring the strange world of quantum mechanics, the expanding universe, and the holographic principle can offer us a glimpse into the true nature of reality. It is a journey that challenges our intuitions and forces us to rethink our place in the cosmos. Quantum mechanics, the theory governing the microscopic world, is full of paradoxes that defy our everyday experience. One of its most baffling phenomena is quantum entanglement. Two entangled particles, no matter how far apart, are linked in a way that defies classical physics. Imagine two spinning coins, one always landing on heads, the other always on tails. This is entanglement. Measuring one coin instantly determines the state of the other, even if they are light years away. This spooky action at a distance, as Einstein called it, suggests a reality that is interconnected in ways we're only beginning to grasp. Another quantum oddity is non-locality. Particles don't seem to have definite properties until they are observed. It's as if reality is not fixed, but is created by the act of observation. This raises profound questions about the role of the observer in shaping reality. We know the universe is expanding. Distant galaxies are moving further apart, their light stretched into longer wavelengths, a phenomenon known as redshift. But what if this expansion is an illusion, a trick of perspective? Some physicists propose that the universe is not expanding into pre-existing space. Instead, space itself is being created, stretching the fabric of the cosmos. Imagine a balloon with dots drawn on its surface. As the balloon inflates, the dots move apart, not because they are moving through the balloon's surface, but because the surface itself is expanding. This mind-bending concept challenges our intuitive understanding of space and time. It suggests that the universe is not a fixed stage, but a dynamic entity, constantly evolving and reshaping itself. Moving deeper into the rabbit hole, let's explore the simulation hypothesis, a thought-provoking theory that suggests our reality might be an intricate simulation. Like characters in a complex video game, we could be living in a created universe where every action, every event, and even our thoughts are programmed by an unseen force or advanced civilization. Philosophically, the simulation hypothesis is a modern extension of ancient skepticism. Plato's allegory of the cave taught us that what we perceive might merely be shadows on a wall, far from the truth. Descartes wondered if an evil demon could be deceiving us, presenting a crafted reality. These age-old considerations have evolved, suggesting our universe might be a construct, akin to a simulated environment. From a scientific angle, this hypothesis intersects intriguingly with quantum mechanics and the puzzles of consciousness. If our reality is indeed a simulation, it could explain bizarre quantum phenomena like entanglement and non-locality. It also raises fascinating questions about consciousness. Is our awareness merely a programmed illusion? Are our choices predetermined by the parameters of the simulation? Despite its allure, the simulation hypothesis faces significant skepticism, primarily due to a lack of empirical evidence and the challenge of testing it scientifically. Critics argue that without testability, it verges on pseudoscience. Yet proponents believe that as technology evolves, especially in quantum computing, we might soon be able to find evidence of this simulation, perhaps even catching glitches in our perceived reality. Culturally, the idea of a simulated universe has permeated the fabric of society, influencing movies, literature, and philosophical debates. It challenges our understanding of reality and provokes questions about free will, ethics, and the very nature of existence. As we ponder these questions, we must ask ourselves, are we players in a cosmic game? And if so, who controls the rules? As we traverse the boundary between science fiction and scientific possibility, let's delve into the intriguing world of testing the simulation hypothesis. Physicists and philosophers alike have pondered if there are physical glitches or signatures that could reveal the simulated nature of our reality. Imagine for a moment that our universe is a grand simulation. If so, might there be detectable inconsistencies in the laws of physics akin to bugs in a video game? These anomalies could range from unexplained phenomena to irregularities in cosmic rays or quantum fluctuations. Pause 2S. One theoretical test involves the distribution of the highest energy cosmic rays. According to conventional physics, there should be a cutoff in the spectrum of these rays, known as the Greisen-Zatsepin-Kuzmin or GZK limit. A violation of this limit could suggest that our universe is not behaving as natural laws would predict, hinting at possible artificial constraints imposed by a simulation. Similarly, researchers have proposed that the simulation might be detectable through anomalies in the theory of quantum mechanics, like the behavior of electrons. Should electrons deviate from expected quantum behavior in a double-slit experiment, it could indicate underlying programming rules. Despite these fascinating proposals, it's crucial to note that such tests are highly speculative and no concrete evidence has yet surfaced. Critics argue that without empirical evidence, the simulation hypothesis risks being dismissed as pseudoscience. Yet the quest for understanding continues as these theoretical explorations push the boundaries of our knowledge about the universe and our place within it. As we ponder these possibilities, we must ask ourselves a profound question. If we were to find evidence of a simulation, how would it change our perception of reality, our ethics, and our understanding of consciousness? The holographic universe. The holographic principle is perhaps the most radical idea about the nature of reality. It proposes that our three-dimensional universe is a projection of information encoded on a distant two-dimensional surface, much like a hologram. Think of a security chip on a credit card. It's a two-dimensional object that contains all the information needed to create a three-dimensional image. Similarly, the holographic principle suggests that the information about our universe is stored on a surface at its boundary, perhaps at the edge of space-time. This idea, though highly speculative, offers a potential solution to the puzzle of quantum gravity, the attempt to reconcile quantum mechanics with Einstein's theory of general relativity. It implies that our experience of space and time might be an emergent property of a deeper, more fundamental reality. The limits of perception. Our senses are limited. We only perceive a tiny fraction of the electromagnetic spectrum, and our brains filter and interpret sensory information, constructing a model of reality that may not correspond to the real world. What if our perception of reality is just a small window into a much larger, more complex universe? And what if there are dimensions beyond our perception, forces and fields that we are blind to? The limits of our perception are not a failure but a challenge. They spur us to develop new tools and theories to probe the universe beyond the reach of our senses, to unravel the mysteries that lie hidden beneath the surface of reality. Beyond the veil of reality, the quest to understand the true nature of reality is an ongoing journey. Quantum mechanics, the expanding universe, and the holographic principle offer tantalizing clues, challenging our intuitions and pushing the boundaries of our knowledge. While we may never fully grasp the ultimate reality, the pursuit of this knowledge is what makes us human.